7-2, solving exponential equations. Solving means to find the value of the unknown. So in this first equation, we solve for x. Or we take the cube root of both sides to solve for x. Or over here, we're going to do multiple steps to get x by itself. New vocabulary: exponential equation, compound interest. Let's take a look at exponential equations and a property called property of equality. What this says is if the bases are the same, then the exponents are the same. If the exponents are the same, then the only way they can be equal is if the bases are the same. So for instance, 3 to the x equals 3 to the fifth. Then I know that the exponents must be the same. If the exponents are the same, then take any base to that power and they'll be equal. So to solve an equation like this, what we want to do is we want to make sure that the bases are the same. So what we'll try to do is work with the number 9. And the number 9 can be written like this, 3 to the second power. So when we do that, we can do pow, 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 multiply me now, and we get 3 to the 8th. Now that the bases are the same, we can say x is equal to 8, and we have solved for x. Let's take a look at this problem. We want to ensure that the bases are the same, and then we can equate the exponents. So we're going to take the number 4, and we're going to rewrite it, and then we're going to use pow, pow, multiply me now. We're going to multiply this and this. So you're going to multiply 2 and 2x minus 1. And that's going to create this. Now that the bases are the same, we can say the exponents are equal to each other, and then just solve for x. Okay, let's go ahead and do it again. This is 4 to the 2n minus 1, and then this is going to be 4 to the third power, because 4 to the third power makes 64. Okay, now I can take the exponents and set them equal to each other. 2n is equal to 4, n is equal to 2. So I have solved for n. Over here, this is 5 to the 5x power. I want to make 125 into 5 to some power. So this will be 5 to the third power. Now I can again do pow, pow, multiply me now. So I can do 3 times x plus 2, multiply those two. And this is going to be 5x power, 5, and then this will be 3x plus 6. Now that the bases are the same, I can equate the exponents, make the exponents equal to each other. So this is going to be 2x is equal to 6, x is equal to 3. Okay, your turn. Pause to do the problem. And here's the answer. Pause to do the problem. And here's the answer. Let's take a look at an applied problem. Here is the general exponential equation. And it says in 2000 the population was this amount. In 2007 it was this amount. Write an exponential function that can be used to model the population of Phoenix. Write x in terms of the number of years since 2000. So we're going to let 2000 be our 0, or our initial condition, initial value, 0, and then this is the value at 2000. 7 years later, notice how I don't write 2007, but 7 years later, this will be the population. So I have 2 points right here. I'm going to take this point and I'm going to substitute it in. I put 0 in for x and this in for y. And remember that this just becomes 1. And so A is that. Now a lot of you can actually just look at this initial condition and put it right here without going through all this work. Now the next step is to take this equation and substitute the next point in. So I'm going to substitute the y. I already know what A is, B, and then I have to the 7th power. Now I'm going to divide by this number to isolate B to the 7th power, and then I'm going to take the 7th root, and then B will approximately be 1.0196. Now, since B is a number bigger than 1, then I know this is a growth problem. And here's what the growth problem looks like with the initial value and the growth factor here. Next question says it has the same stats for 2000 and 2007, but now it says to predict the population of Phoenix in 2013. So what it's asking is let x equal to 13 and try to find y. So we're going to try to find the population at that point. So I'm going to write y equals, and here's my initial value at time equal to 0. 1.0196, and now I'm going to take it to the 13th power. We're going to put it in our calculator, and I get approximately 1,700,220. I should say 21 when I round. Okay, so this is the estimation for the population in 2013, which seems reasonable because it's higher than in 2013. Okay, you try it. Same type of problem. You notice it's still 2000, 2007, different initial value, different time here. So go ahead and use those times to try to find your growth factor and the appropriate function. Pause. And here's the answer. Here's how I went ahead and solved it, put down my 2 points and went ahead and solved it to figure out. And this was B, and this was the B that D I wanted to choose. I didn't want to have x minus 7, just plain old x with my initial value. All right, let's go ahead and try to use your equation to predict the population in 2020. Pause. And here's the answer. All right, let's talk about compound interest. You work out the interest for the first period and add it to the total and then calculate the interest. So suppose we're adding 10% interest every year. And let's see what the loan looks like that we're going to have if we don't pay off anything. So suppose we get a $1,000 loan. They're going to charge us 10%, which is $100. So after a year, you're going to owe $1,100. And after that, they're going to take 10% of that number, which is this. They're going to add it to what you owe, and this is what you're going to now owe. So what it is multiply and then add, multiply and then add, multiply and then add. But there's an easier way, and let me show you how we do that. Instead of multiplying and adding, what I can do is multiply by 1.10. And the 1 is 100%, and the 0.10, well, that's the interest. So if you write 1.10, you're actually going to have a growth factor. So this number will actually grow to $1,100. And that's what we had before when we multiplied and then added. So in year 2, just multiply by 1.10, and this is how much you will owe, and so on. So in fact, from the start to year 5, what we're doing is more multiplying, but these 5 we're multiplying, because each time you multiply, then you're creating the amount that you owe on each year. So this is what you would owe at the end. Now, when we look at this, it looks very much like our growth, exponential growth general equation. Here's my initial condition, here's my growth factor, and this is how many times I do it. Now what we're going to do is we're going to write it just a little different way. You can see this is still going to be initial condition. This is still going to be a growth because it's adding R, and R is going to be the percent that we're doing. So instead of writing a B, we're going to write it this way, 1 plus R. And then instead of writing X, we're going to write T, because T is going to stand for time. Now let's take a look at compounded quarterly. Now this is $1,000, the same problem before, but you are not going to owe 10% right away. After 3 months, you are only going to owe 10% divided by 4. So the increase isn't the whole 10%, it's just 0.1 divided by 4. And this is how much you'll owe after 3 months. Now this whole thing right here represents quarter 1. Now we're going to take quarter 1 and we're going to times it by the same growth factor, and when we multiply by that, we're going to get a new number, and this is how much we owe after the second quarter. Now to figure out the third quarter, you're going to take your second quarter, this is the second quarter amount, and you're going to multiply it by the same growth factor, and this is how much you're going to owe. Now we're going to multiply the third quarter, this is the third quarter right here, and you're going to multiply it by the same growth factor, and it's going to be this, and it's going to be approximately this. Now when we only multiplied it once a year, we only owed $1,100 after 1 year. And when we compound quarterly, notice that you owe a little bit more, and that's because you're gaining interest on the interest. So that's why this number is bigger than this one. Okay, in general, the compound interest formula looks like this. So again, when we write y equals a times b to the x power, this is going to be the initial amount, and our b is our growth factor. Remember, adding, and this is the rate divided by how many times you're going to compound, and these are the number of periods. So you're going to take the number of years and how many times a year you're compounding it. And you're going to multiply these two to show you how many times you do that. Okay, let's go ahead and do a problem. So I went ahead and wrote out the problem. Let me go ahead and identify each letter. So P in our problem is the amount you start off with, and then R is going to be change it to a decimal, and N is how many times you're compounding it, and it tells us quarterly, which means 4. And the question and the number of years, T, is equal to 8. So let's go ahead and put our numbers in. So it's 4,000, 1 plus, then we're going to write 0.054 divided by 4, and then we're going to take 4, and we're going to times it by the number of years, and the number of years is 8. And you can see it's going to be 32 times that it gets compounded. And when you do this, you're going to get, after you multiply this out on your calculator, you're going to get this number right here. Okay, so let me go ahead and do it again. Here's the answer I'm looking for, but really what I want to practice is setting up. So the amount, let's go ahead and write it out, is principal 1 plus R over N, the number of times it's compounded, N times the number of years. So my P in my problem is $100. The R in my problem is 0.012. Remember, you must change the percent to a decimal. And the number of times it's compounded, it says twice a month. So if it's compounded twice a month and there's 12 months, that means there are 24 times that it gets compounded. And then T will be equal to 20 years. So let's go ahead and put all those numbers in. 100, 1 plus 0.012 divided by 24, 24 times, and the number of years is 20. So that's how many times it's going to be compounded all together, and that will be approximately this answer right here. Okay, your turn. Pause, write out the problem, and go ahead and configure it. And here's the answer.